We will now enjoy a dynamic discussion led by Michal Geva. Michal is the founder and managing partner of Triventures, a venture capital fund focused on transformational health and includes medical devices and data-driven digital health technologies in Israel and the United States. Michal has over 20 years of experience in medtech startups, both in Israel and the US, in a variety of executive positions, and she will lead the Startup Corner, featuring some of the most exciting startups in Israel. As well as Dr. Peter Fitzgerald, who is a professor of medicine and engineering, as well as a director of the Center of Cardiovascular Innovation at Stanford University Medical Center. Please welcome to the stage. צריכה מצגת? יודעת איפה היא או שאני צריך למצוא אותה? That's your... Great. Thank you.
Good afternoon, everybody. So we've been talking a lot about cybersecurity, safety, privacy, data, and data liberation. And we are going to take the next few minutes to listen a little bit about the perspective from the world perspective, not just the Israeli one, about transformational health. The reason we have so much issues with data and cybersecurity is because the world has become flat and the healthcare is undergoing a huge transformation. We're seeing more and more things that are connected, more access to data, a lot of interest to connect data, and the dark side of this connectivity is actually the cybersecurity. This is why we see in the last couple of years a new phenomenon that is in the increase of attacking healthcare in order to get to devices and data. And in the next few minutes, we're going to hear a presentation from Peter Fitzgerald, my partner at Triventures and professor at Stanford, about the challenges and opportunities. Then we're going to invite two gentlemen to the stage that are running startups. We're going to have a discussion, and hopefully it's going to be a little bit more interactive with you guys about this sector. So, Peter, please, the stage is yours.
Great, thanks. Thanks, Michal. It's a pleasure to be here. And as a physician, I'd like to just take a few minutes and talk about the excitement of some of the digitization technology that's been integrated into healthcare, some of the advantages that we've seen for all the Ps being patients, physicians, payers, and practices. And this is what, in one of the most exciting eras that I've seen in the 30 years that I've practiced healthcare. When I started, I carried around one of these things, and I'm not sure what I carried in it anymore. But clearly, things have changed today. We are embracing this digital phenomenon into healthcare, and it's having a drastic effect on how we measure. You just heard Zeev talk about how we can get population queryable statistics and really begin to learn from our practices that are quite scattered throughout the whole world. The behavior of people, as half of you are looking at your cell phones right now, which we used to look down when we started this journey and now still look down because you folks touch your cell phones, not that I'm not guilty of this, 650 times a day. You interact with them 150 times a day, and that's 8 billion times a day just in the United States alone. So that, I don't want to necessarily judge that maneuver, but the power that it has with respect to patients is amazing. This is something we did with Jeff Williams, who's the COO of Apple, and we empowered patients to enroll in this cardiovascular fitness study at Stanford. We enrolled 40,000 patients in 3 months, the largest enrollment that's ever happened in the history of trials, and there's 175,000 trials that happen per year around the world. That sort of empowerment really implements personalization, the predictive, preventative, and participatory process of patients. And this is the first time patients have been empowered with being able to not just listen and take notes from a healthcare professional, but actually be involved in that complete cycle of care, if you will. The computer powers that we see today has exponentially increased our ability to analyze, such as real-time values of a heart, which 2 years ago took me 45 minutes to interpret and 45 or 15 minutes on top of that to analyze. Today, you can do that in 60 seconds for both. And those are facilitating decision support systems as well as helping us with respect to patient care. We can analyze 20,000 chest CTs in 2 minutes, augmented by a training set for such machine learning, similar to what you can do with a human, but in a much faster rate. 250 stress echoes can be done within 5 minutes, and the CPU interpretation of pathology, tissue biopsies is far more accurate and much, much faster than what we can do with the human today. We see a wearable decade, everywhere from tracking your uterus to tracking what you eat through your teeth. Those are important in some processes, but those data need to be corroborated in a way that's meaningful as we track behaviors of our patients throughout their journey. This is an example of sort of an active device, if you will, one that you put on your forehead, that you rub your cell phone against, and it gives you your instantaneous glucose. There's bands that you can put on your wrist that can give you your instantaneous glucose. Now that helps not only if you're a diabetic, but we have 90 million pre-diabetics in the United States. So it may help prevent or bend the curve for when they become or when they need insulin. Remember, these folks, as they interact with this conduit, not only become consumers, but become data proliferators. And that's an important issue, again, with respect to following the temporal assessment, the temporal finding of how those patients or people react with respect to meals and react with their underlying disease process. That temporal information can feed back in a reinforcement learning mechanism to get better at judging how the next person that looks like this person can benefit from therapies. So having that individual footprint, and as Zeev talked about, then having population analytics, coupled with what we have in healthcare, and that is images of those people, gives us a triad, a foundation that's stronger than we've ever had for making decision support systems, decision support analytic pathways in our healthcare system. On the top of this industry, we're seeing a convergence. Now 22 million people that have and are insured by Aetna can go to get their health care in 10,000 locations. If you're Cigna and you're 12 million of those people, you can visit 700 pharmacies and get treated by 500,000 physicians instantly at some of the healthcare pharmacies that are at your cornerstone. So we see a tremendous change both at the bottom from respect to patients and at the top with respect to policies. This is why the Googles, the AWSs, the Qualcomms, the Apples are beginning to come into healthcare. Remember in 2006, if you took the top 10 companies, 5 of them were related to oil. Today there's none that are related to oil. 7 of the top 10 are data related. The only one that's common between those two is Microsoft. So there's been shifts at the base and shifts at the top that is really overturning what we've appreciated in healthcare in the last 30 years. Virtual hospitals are cropping up all over the place in the United States, where in a hospital you don't have patients, but you have 24/7 people sitting in front of those terminals that are connected to those patients that may be 9 miles away or 90 miles away. Again, a very efficient and provocative way to take care of patients in a more uniform way than we've ever had before. Tim Cook stood up about a year ago during the Apple meeting, held his phone, walked across the stage, showed his EKG. We're seeing that sort of involvement with respect to those IT companies, and that's an important augmentation. Today, we're seeing whole exome sequences, and I like the analogy that was given here. We gain that value in that asset over time because we can connect those now with machine learning to the phenotypic expressions. Histopathology learning from computers are far better than humans at being able to spot cancer from biopsy. Protein folding, something that is very complex, can be accelerated with our computing power for drug discovery. Triaging patients effectively to the ER, within the ER to certain parts of the hospital, and once they leave the hospital into care facilities. All that can be done with data at a base. So we're getting much, much better at being efficient for healthcare. The bad side of that is something we've been talking about today, and there's always a dark side to the light side. And the light is what we've just appreciated a little bit, but there are some dark sides, and we're seeing a tremendous amount of hacks that are occurring in our hospital systems, that are occurring with our PHIs, that are occurring with our personal implants. This type of thing is pretty simple to do because the fact that these are old Chevys, if you will, that have old operating systems in it because they don't want to change because they were FDA approved. But you can do that. The problem, and I think we're going to talk about this on the panel, is why do that? You can do it much more efficiently with a gun. So there has to be an underlying business mode in order to see how these black hackers begin to think about. 85% of the hospitals were hacked within the last 2 years. And it's not just a hospital. As Zeev pointed out, data is important, devices are important, and the home, which becomes a recipient now of these implants, is an incredibly important issue. If you look at enterprises compared to healthcare, the data breach cost per capita is highest for healthcare. And I know we have many other modules going on throughout this campus, but this one, with respect to healthcare, has the largest economic impact that you're going to see. And part of it is because those assets grow over time. And it's all about these nodes, these vulnerable nodes, whether it's an MRI machine with a USB that's being used to charge somebody's phone that just happens to be running the MRI machine, or whether it's one of these infusion pumps, again, that are hooked to the network. And we, as healthcare providers, bring in our iPads, our iPhones. The families bring in their iPads and iPhones. And this creates vulnerability because the number one threat in a hospital are the employers, are the people that are there. And they don't do it nefariously. They don't do it on purpose, but they have contamination in the nodes that they bring in that ultimately get into the nodes that you can get access to EMRs. And what happens when you get a healthcare record? And now remember, when you get into one of those EMRs, they're not segmented, they're not duplicated like cloud security. They're all there, hundreds and hundreds of thousands, as was illustrated early this morning. And once you get your Social Security number, you file erroneous state and local taxes. Once you get your medical record, you file state, Medicaid and Medicare. And once you get your drug history, that's one of the components to this opioid crisis, you sell that on the black market. These three things, Social Security number, medical records, and drug history, go for about $150 on the black market, times hundreds and hundreds of thousands that you can get. So the threat to having a hospital have to admit that they've been hacked is a huge PR issue, and you can see the shifts in healthcare recipients because now patients are empowered. That means significant amount of dollars. The Internet of Medical Things are those technologies within the hospital. They have to come through a funnel of usually FDA approval. So they're less, they're few, but they are connected to the internet. They're connected to the network. But being able to follow those IP addresses is an extremely important issue. And as you follow them over time, you can begin to characterize that's an MRI machine with this operating system, with this particular set of hardwares. There's an IV pump in room 223. We know exactly what the characteristics are, and we begin to follow what the patterns are and begin to see if there are any abnormal patterns that occur over time. Because remember, visibility is the foundation for providing any security. So as you look across your network in a hospital, and if you go to ask the CSOs or the CIOs of hospitals, at least in my country, and you say, how many devices are on your network? The answer is usually 4 letters, a lot. They don't know the number. They don't know the characteristic of what's going on temporally. But as you begin to do this, and several startups are doing this, you begin to see the characteristics of those pacemakers that are in patients in the hospital, or those MRI machines, CT, IV pumps, or even fire alarms, because those are on the network. Again, understanding the characteristics and looking for deviance is the first baseline, the first alphabet for providing a paragraph of protection. Think about also being able to see the activity of those IV pumps up on the 3rd floor compared to the IV pumps on the 1st floor, and begin to understand that you can do inventory management because you don't need to do routine type of helping those, secure those particular items if they're not in use. So having inventory management by knowing the longitudinal expression, if you will, of those IP addresses is extremely important. So we have the Internet of Medical Things, and we have that interaction with the network. There's usually some antivirus protection within hospitals, and there's a firewall, but that's usually about it. But now remember, when all those implants that I put in patients, they go outside into the IoT environment at some point, and they need to be protected. So again, that's where the home comes in compared to the hospital, data and devices. So most hospitals have firewalls and antivirus, and they have a lot of cyber insurance. And cyber insurance is an important element for what's going to go on in the future. Today, it's very limited. If you have a hospital and you want cyber insurance, you just get it. There's no actuarial limits to it. We're seeing accreditations of hospitals need security. We're seeing the FDA demand security provisions for their implants. And we're seeing consultants, and we're going to talk to some of them here, that are forming opinions and advising the CEOs and the board of hospitals, which is an important issue. So in conclusion, the digital era in medicine is empowering for patients and efficient for that continuum of care. Healthcare is vulnerable and in need of solutions for hospital, home, data, and devices. Rapidly growing active implants will need IoT security as these artificial pancreases, deep brain stimulators, pacemakers go out to the home. IP address visibility and temporal contexture across IOMT is the first phase, if you will, to providing security inside a hospital. And ultimately, that's the best we can do for patients and provide the best care over time. Thank you for your attention.
Thank you very much, Peter. It was fascinating. Alon Kaufman, can you join us? And Amir Magner. Great. So Alon and Amir are running 2 different companies that are in the cybersecurity for healthcare. I'm very glad to say that we at Triventures see about 500 different companies every single year. It's only in the last 2-3 years that people have started to appreciate the need of specific technologies in this. And we have here in Israel several, probably a couple of dozens cybersecurity companies for healthcare. And I would love, if it's okay with you guys, first of all, maybe Amir, you could tell us a little bit about the company today. Amir is the co-founder of CyberMDX. He served in the Israeli Prime Minister office for 2 decades. And in his last position, he was the head of the cyber division. As part of his position, Amir's responsibility including managing some of the most critical national strategic activities and infrastructure. And a couple of years ago, you started a company called CyberMDX, and maybe you can give us a little bit brief about this company, what it does?
Representation.
Okay. Where is that? Oh, yes. Put it here.
God knows. No, I forgot.
Organizers, somebody? זה לא זה? רגע, אתה רוצה לעשות את זה בשלך? כי עכשיו אני צריכה... אז זה של אלון אני פשוט צריכה להעביר עכשיו, כי זה לא עבד לי. אז אתה רוצה לעשות שלך ב-USB שלך?
רק תעביר את זה למחשב.
רגע, אוקיי. זה הכל עכשיו על הדסקטופ.
Okay, it's all about the human factor. As you can see, Peter mentioned it, and I think definitely it's part of the problem. Thank you for the introduction, Michal. I think we had quite a few sessions talking about the cybersecurity concern in healthcare, and also for hospitals and medical devices. So I won't go into the background. I just want to give you our view of the problem, but a very practical view, and I will show a movie made by our research team that illustrates, I think, not in theoretical aspects, how deep and how fundamental is the problem for cybersecurity, specifically for medical devices. So it's a 2-minute movie, but I think the important thing is how fundamental it is.
How easy is it to hack into an infusion pump? In less than 20 hours, with fewer than 200 lines of code, we were easily able to hack into a syringe. This syringe is the industry's most popular brand. See the pump rate at 2.10. Infusion is started or stopped with a simple press of a button. Notice the aggregation of the total dosage. Even at a closer look, it is hard to notice the syringe's progress. Now let's get connected to the hospital. The syringe communicates using a serial port, which is not compatible with standard networks. A terminal server is required to bridge between the two. Let's connect everything together. A laptop with our malicious code will also be connected to the same network. It's hacking time. First, we broadcast a discovery signal through the entire network, which causes each of the terminal servers to respond and identify. That's how we get their IP. It's that simple. The terminal server supports connecting multiple devices. Here we scan its devices looking for our syringe pump model. Once the syringe is located, we open a communication channel. With it, we are able to send it remote commands. A hacker can control the syringe, instructing the pump to operate at a faster rate. This is happening with no physical interaction and no footprint of malicious activity. Alarms suddenly generated by the machine are also remotely muted. So simple, yet so horrifying. This illustrates how incorrectly connecting a medical device to your network can lead to devastating results. So how protected are your critical assets? How easy?
So, as I said, and I think Peter gave a great background about it, it's really something, a huge gap, and in a nutshell, I review CyberMDX and its solution, very high level. CyberMDX delivers zero-touch solution, securing medical devices, clinical network, and the critical assets for hospital. The very basic solution starts, and Peter also touched it, with the greatest problem of creating visibility for the medical devices, generating in-depth and continuous automatic visibility. As mentioned, most of the hospital do not know how many devices and what is their profile, so this is the very starting point to any kind of security solution. And on top of it, we are creating an assessment and detection solution to detect vulnerabilities and threats incoming to the network and to these devices. And the last and not least is creating a prevention solution based on a machine learning technology to create smart isolation for each medical devices, creating personalized firewall. And as also mentioned here, the most important thing is that technology should fit to the hospital workflow, to the different teams that are managing these devices, the biomed, the IT, the security team. So it should be a combination that support their workflow. So in a nutshell, this is what we are doing. I think the background was great for just getting you into business, and we'll follow up to the panel.
That's great. Definitely a lot of need for those kind of solutions today, as we heard from the different speakers. And before we start talking a little bit about questions, I'd like to introduce you to Alon Kaufman. Alon is the founder and CEO of Duality. Alon has almost 20 years of experience in high-tech arena, commercializing data scientist technologies and leading industrial research and corporate innovation teams. Before he started Duality, he was in RSA, and he was the global director of data science and innovation. And after you hear what Duality is doing, you'll understand why data science is so important in his background. So, Alon?
Thanks. So, excuse me, I was invited to a panel, so I didn't prepare movies or slides and so on, but I do have something just as a background slide, or maybe. You don't have it? Yeah, maybe I'll just show. This is the second, no, this kills the previous one, yeah? Where did she put it? Excellent. So this is a background slide. So Duality really looks at this world, and we spoke a lot about data, endless devices creating this data, the fact that personal data is, of course, sensitive, expensive, and so on. But the bigger question is actually, what can you do with this? And how do you actually improve outcomes, improve healthcare, and so on, using this data? And of course, healthcare is not the only industry. Many of the industries today around data are actually asking those questions and using tools like advanced analytics or AI to solve these problems. And Duality is really focused around providing a secure environment to do what we call digital collaboration. Now, digital collaboration is anything where two or more parties are combining data sets to get some kind of value out of it, or a data owner is collaborating with what we call an analyzing party, which wants to apply some analytics to the data and so on. So collaboration is any time where two or more parties are coming together to analyze something. Now, obviously, this is critical in this world. So wearable devices has to be linked to clinical data, has to be linked to genomic data, and so on and so forth. You want to sometimes combine data from medical centers and foundations and so on. But the big challenge there is, although that there's a huge value in this collaboration, collaboration by definition actually opens up to exposure. So the whole day we were talking about how do you protect your data within your perimeters, within your devices, but when you want to collaborate, by definition, you're opening up your data. You're giving it to someone else or trying to work together. And that's exactly what Duality is really trying to solve. The fact that when you collaborate, you basically open up your data, lose control on the IP of the data, lose control of what's being done with it. That's really what we are trying to solve. And we have a very unique novel technology which actually enables to analyze data while it's encrypted, without ever decrypting the data. And you can see the founders. We have an extremely strong scientific founder of Duality, people, Professor Shafi Goldwasser, that has a Turing Award in the space of what's called secure computation. Professor Vinod Vankunathanu, who actually invented the algorithms to make these things come true. And Kurt Rohoff, our CTO, which actually has been implementing these originally in DARPA kind of insurance worlds, and now we moved on to really provide this platform, which I'll talk about more, to enable collaboration without really exposing data at any time throughout the process. Thanks.
That's great. Thank you, Alon. So maybe we'll start with you, Alon. You know, we've been talking about encrypted data, and we heard from Ziv about cloning the data, creating synthetic data. So maybe you can share with us the pros and cons about each one of them, because eventually it's all about liberating data and enabling bigger analysis capabilities.
This one works. Excellent. So this world of data is a huge world. So there's many, many actions you can do and so on. Duality really, or encrypted data, is focusing on really 3 points which probably you can't do with simulated data. So the first one, imagine, let's say, take an example of Peter. I have an image and I want to get some kind of radiologist risk score or diagnosis. So I have my genomic data and I want to get some treatment. So when you're utilizing this kind of what's called AI in healthcare, I'm sending my personal data to get a service. So you can't simulate or you can't synthetically develop my data. So this is one type. So when you're looking at individuals or looking at small sets of data, there's nothing to statistically play around with. That's one case. The second case where we talk about collaboration. So if I want to actually combine clinical data and genomic data on the same individuals coming from two different entities, let's say Foundation Medicine providing clinical genomic data and some kind of health provider the clinical data, and you have to match it on the patient level, this, of course, you have to have the real data there. And the third example, or the third thing that Duality is really focused on, data owners, be it foundations, pharma companies, providers, insurance, have a lot of concern about what's being done with their data. So there's a lot of legal agreements, what you're allowed to do, what you're not allowed to do, and so on. And by encrypting the data, encrypting is basically, you can just imagine it's taking your data, locking it in a box, keeping the key to yourself. No one else besides the person with the key can actually use their data. So it's not a matter if you
Those
can
are the
simulate
pros, right?
Sorry?
Those are all the good things. What are the bad things in terms of time it takes, the analytics that takes more time? Do you see this in your technology, and would it become a barrier?
So it's not a barrier. There's obviously a huge challenge taking the process of data science and AI of today and basically putting in new technologies. Anyway, healthcare is not so easy to introduce with new technologies, so even jumping a leap forward and introducing these kinds of technologies is more challenging. But encryption is used today already. So it's used in REST, it's used in transit, and now we're actually adding the use in the computation. So there is understanding and processes to get it in, and it's just a different way of collaborating with really enforcing by encryption, as we've been doing today in other areas.
I think it's more personalization protection than population. Because what Ziv was talking about is when you want to query a whole population and look for trends, you are able to make synthetic data. But with yours, you personalize. If I want to send my data to Foundation, and I think as patients become more empowered, that's going to be more.
So it's also the personalization and also the control. How do you know what's being done with your data out there? Even though it's synthetic or not, you want to have control on what's being done.
But the downside of that is I've got to give the key to somebody else, and I don't know what they're going to do when they unlock it.
Excellent point. So you should never give your key away. You should never give your key away.
You have to if you want the other side to be corroborative to you and with you, especially if it's my OMIC data and I'm going to foundation. So there is going to be vulnerability on the foundation side.
So the amazing thing with this technology, and really, I especially put on these founders, each of the parties encrypt the data. We do a joint analysis of it. No one ever sees the other one's data, and no one ever shares keys. Everything's there, really. And it's quite amazing that you get the results out without really seeing the actual data there.
Okay, so that's about data, and I want to be sensitive to time before they kick us out, but two more questions. Maybe, Amir, to you. You've been talking about the security within the hospitals, right? In the Internet of Things in the hospitals, today we have more of Internet of Medical Things that are starting in the hospitals, are going home with the patients. Any thoughts about that? What are your thoughts in terms of enabling security for the continuum of care for patients in and out of hospitals?
Definitely. I think it's a great challenge. In the beginning of the millennium, we have talked a lot about securing enterprises, data, and devices. I think in the recent few years, we are talking about the IoT, so securing physical assets. And when we are seeing how things are evolving, we're definitely talking about securing human beings, because implantable devices or devices that are coupled with our bodies are different kinds of situation. And I think two basic things will be needed, assuming that these devices are really critical and the software will still suffer from unpatched devices, which I believe will be the case because of the fear to update or to make any kind of patching to these devices. So one should be hardening and limiting in the right manner the communication and the access to these devices. And for example, a very basic thing, so you don't need all the time control communication for these devices, but you might need telemetry. So hardening the access and the communication would be the first thing. And the other thing, I think we'll see more and more solution monitoring the traffic. So as Peter showed, using machine learning and AI to recognize any kind of deviation or anomalies in these devices and to create a prevention mechanism outside, and it should be covered over the traffic. So I think these two would be probably the best practices to handle this challenge, but definitely it's going to be a great challenge.
Yeah, talking about challenges, we heard a lot about the integration into the healthcare system. We heard in the morning for the people that were here, healthcare hospitals CEOs saying, maybe we have a problem, we don't have the budgets, or maybe we don't understand enough the importance of this problem. You guys are going today and knocking on doors for piloting and to find clients in probably the States. Who are the people that are you targeting? Is it the chief information officers, chief technology, chief security, CEOs? Is it the insurance companies, the advisors of the world like Deloitte and others? Where are your points that you're putting the effort?
Yes. So I think the good news is I think the awareness is really growing. And I'll start with, the executive in the hospital. They're really aware to the problem, and I think also budgeting it in the right manner. So the basic target for us as a cybersecurity solution would be the CIO and CISOs. But what is interesting, we are seeing lots of involvement of the biomed clinical engineering team. Which I think is really important because we are talking about a multidisciplinary problem. This is how we believe should address it. And CyberMDX focus is on medical devices and clinical network. And I think I tried to illustrate it in the movie and what our research team is doing. The current solution, the traditional solution, leave behind medical devices. And the basic reason is you don't have antivirus on the devices themselves. The firewall and the network solution can't really see these devices, so it's a matter of coverage and granularity. No coverage for what we call the lateral movement in the network. So if you can't see these devices, you don't have any kind of protection on these devices, and these devices, we should say, are connected by nature, because today all the devices are mesh connected to control system, and to the holy grail of the hospital, to the EMR, to the PACS, to the data center. They are all together connected. So if they are very vulnerable, you get access to everything in the hospital. It's a very good pivot point for hackers. So this is the reason we believe that there should be different approach, and the solution is built bottom up around medical devices, the clinical network, and the understanding of the semantic of how hospitals' network is working and what is the right workflow to support it.
Can we defer this question, with my apologies, to side discussion? Because we're really behind schedule. Excuse me, sorry. Thank you very much, panelists.